okay.
Well, you have to compare it to SAS.
Did you want to start?
Yeah.
But that's it, I haven't really used either for a really long time, so. Hopefully it's a lot next one.
Today, we're going to do our first lab, an hour on R. I don't want to give people the idea that I'm proselytizing, though I didn't notice that I'm wearing my R hoodie again. There are other systems you can use. As we're talking about, STATA is a very nice system. There's a huge commitment to SAS at this university, more so than I was accustomed to in Montreal, certainly. SPSS. JUMP, which is a kind of scale-down point-and-click interface to SAS, is also getting more popular. But and really, the system, when you're doing your analysis, you basically want to choose a system that you're comfortable with and that you can get support in. CHI, where who's building your sitting, supports officially SAS and R. But different supervisors use different things. All of Celia's residents use STATA, learn STATA, because that's what she uses, and she maintains a separate terminal for them. So you're going to choose. I would advise you, no matter which system you choose, there's going to be a steep learning curve. And so before you put the energy into it, think about whether or not you have long-term needs, and because it makes sense to invest that energy in something you're going to stick with for the longer term, and that's an advantage of R. I've shown you this quote several times because I quote it all the time, that R is really now overwhelmingly the choice of professional statisticians. Part of that is because we are cheap, and I'll tell you just an anecdote to confirm that. But, the American Statistical Association met in Las Vegas a few years ago, and they don't gamble very much, and everything in Las Vegas is subsidized by the casinos, so we were invited never to come back, which I think is rare. R, as you know, is an open source package. We've talked about it. There are a couple of point-and-click interfaces. We're going to focus mostly on the command line, where you type in commands. We are not going to teach you how to do programming. R is a fully functional programming language, and you can create your own programs, your own functions, your own add-on libraries. We're not going to teach you how to do that. We're going to teach you how to use the built-in commands and the built-in libraries. There are many, many resources for R on the internet and in the library. The R book by Michael Crowley at the Imperial College in the UK is, I've chosen it mostly because it's available electronically, so you can, it's 1,000 pages long, but if you're doing analysis of variance, you may want to choose read the chapter on analysis of variance. There's lots of command examples to copy and paste. Quick R is actually a website maintained by Rob Kabikoff, and it doesn't have much theory, but it is a great place to find command examples to do anything from introductory to advanced statistics. And these are free resources that are available online. There are other textbooks, and there are also online user forums like RSeek, where you can ask other users for help. And my experience has been that even if it's 3 in the morning, somebody somewhere in the world is up using R and will answer your question. If it's Brian Ripley from Cambridge, turn off your computer. He's a very smart and famous statistician, but he's abusive. In any case, there are lots of resources, and some of them we've outlined in the notes. This is the R Studio editor, which we've asked you to install, and I'm just going to go over its basic elements first. This is the script window where you type commands. You'll see here that many of these lines begin with a hash mark. That just means it's a comment. So anything from the hash mark to the end of the line is a comment, and it won't be executed. So this is where you explain to yourself what you're doing, and if you're like me, please keep detailed notes, because I don't remember 2 days later what my logic was, and I need to be reminded. And so you'll see most of my code is more comments than actual code. For the most part, you're going to be using built-in packages that come with R, but there are in fact thousands in the library of R add-on packages, which are specialized collections of functions. There are thousands of additional packages for specialized functions, and we're going to meet some of them. And I asked you to install the packages, which you can do either here one at a time from the install packages command, or you can just run this command when you're connected to the internet. So I hope everyone's had a chance to do that. You should have a, sorry.
That top box.
Yeah.
How do we make ourselves have that?
Oh, it's not there on yours?
Really? But I don't mind.
Oh, sorry, I was just going to get that. File, new script.
Okay, thank you.
And in fact, if you go to the downloads folder and you double click on the lab1.r file, it'll open, it's a script.
So, because a couple over here just have a single box.
Okay, so go to the folder where you downloaded the data sets, and you should see in the data sets folder 06 Lab 1 student. And if you double click on that, it will open it should open in our studio.
Does it bring that in Dropbox? Is it there?
They're on Dropbox, the data set? Yeah.
No, is it in the Dropbox?
I have no idea. I don't remember.
The best way to get it is to go to www.statsguy.ca and it's the second link.
They are in the Dropbox.
Okay, it's in the Dropbox. Yeah, that's right. And actually, rather than double-clicking, go File, Open File, and then navigate to that folder and open.
They're not in the Dropbox, not that one.
Okay, so
Are they?
Yeah, they are.
Top one.
There's something I don't know.
Here, why don't you just,
if you go to let's all do this. Go to www.statsguy.ca and datasets and R code right under the primer, and it will. When you click on it, it will download to your downloads folder. And when you open your downloads folder, it should now be unzipped, a folder called datasets. And
so why don't we just pause there?
Yeah.
Go.
everybody's got that folder?
No.
Okay,
No,
let's do that. Yeah, Lab 1.
If we just double click that, should it open that in our studio?
Now, it may be assigned, depending on what your computer, whether it assigned it to R or R Studio.
Oh, it goes to R unless I ask it to go to our studio, okay.
Yeah, so if I had instructions on the primer on how to assign it to R Studio. So if you haven't done that, the safest thing to do is go File, Open, and then open that file. But you should assign it to R Studio at some point because you'll find it more convenient. So yeah, you're good.
Sorry.
And that was
You got it.
lab 6.
So it's MVPs. Oh, actually, to get
Lab one,
the
or
data sets, you don't need that.
And if you double click it, you can make it.
Just the second link, the data sets and R code. Yeah. No.
So Robin's got it, James doesn't.
Okay. So you're the same. You don't need. You clicked on. Oh, sorry. Okay. Now, that's R. So quit that. And that's not R Studio. That's.
You don't want that.
So what you want to do is open R Studio. No, those are, you had to install R and then install R Studio. Okay, well, so it'll take a minute, so why don't you do that? And everyone else? James, you're good?
Yep.
Yep. You're good? Okay. Everyone's good?
Except we have Jesse.
Yeah. Jesse, is it okay if I continue?
Yeah.
Okay. Just tell us if we're getting too far ahead.
No, how do you not? So in terms of installing our studios, or
You just drag it.
it says download our studio?
Yeah. Download the Mac version. Oh, and then download the Windows version.
I don't know. Yeah.
Okay.
You see what's
And then there's a .exe file, I think. You can just accept all the default questions. Say yes, yes, yes.
Can you make 2 6?
No, I don't know if it's always used. It's saved to computer. How did you make it so it defaults to open in RStudio?
There's different instructions for, you have the Mac? Okay, so the easiest way on the Mac is just to hit Command-I after selecting that folder, and down here choose RStudio as the application you want it to open with, and say that you want that to apply to all .r files. And and then they will automatically open with our
So
studio.
4 is not, can I get it correct? I think Jesse's getting our studio.
Oh, I'm just installing it, but I didn't.
You can just go get it.
Oh, yeah.
So that you might.
And there's similar instructions for Windows to assign .r files, so it's just convenient if they open in RStudio. You can use R by itself, but I think you will find that RStudio is convenient and helps organize things. So I'm just going to go over the windows here. This is the script editor window. And here you can write long bits of code, and they don't get executed until you put the cursor in the line and hit Control Return or Control Enter. And then they will be executed. So if you haven't installed those packages, you just put that cursor anywhere in that line, and don't do this if you have installed them because it'll take a few minutes. But you'll see that you can just execute a command with Control Return. When you execute a command, I'm going to type in an example, 3 + 4, and then I'm going to hit Control Enter. The result appears down here in the output window. You can also type commands in this output window directly and hit Return, and they will be executed immediately. So the difference where you type the command depends on whether or not you want it to be executed immediately or you want it to be entered and saved and then executed only when you ask it to be executed. And usually it's the latter, so we enter all our commands in the upper window. The results appear in this console window, and I don't think you ever have to really enter a command in the console window
So
unless
we'll only run one line?
No, you can select 10 lines. That's the beauty of in the console window, it will only run one line at a time.
Okay.
But in the script window at the top, you can create multi-line commands, and they won't run until you...
But you highlight all of them?
You can either highlight all of them, or if it really is a multi-step command, which we'll learn how to create, you can just be in the first line or any line, and it will execute the whole block.
It reads every line as one box
Yeah.
instead of just one.
Yeah. We'll get to that.
Okay.
You'll see that. There are links I've talked about. We're down here. Over here are a couple of useful windows. So this is the environment window, or maybe called workspace, depending on which version of RStudio you have. And right now there's nothing here, but whenever I create data or results or any new, what we call an object, it will be named here and give me some information about it. There's a history tab that shows me all the commands that I've previously run in this session of R, so that I have a running tally of any commands, whether or not they were entered, as you can see here, in the script window or in the console window. But for the most part, we're using the environment window. Down here, we have our plot window, where graphs will appear, and it's also our help window and our library window, which shows us all of the packages that have been installed on your version of R. Now, you probably have 15 or so. I've got several hundred. And you can see none of them are actually loaded yet because this checkbox is empty. And by default, R only loads 2 packages, the graphics package and the stats package. And when it gets loaded, the checkbox gets checked. So you can manage your packages from here, and this is the help window also appears in this tab. So that's what we like about RStudio. It runs the same on Windows and Macintosh, so you can move from computer to computer. And you're gonna see how those windows actually apply in real life. So let us first recognize that R is a very fancy calculator. And as we saw, you can enter commands by typing them in, either in the top window, the script window, or in the output window. And then, as long as your cursor is in that line, Control Enter will execute it, and you will get a result. And so I just want you to feel comfortable doing addition and multiplication and division and exponentiation, which uses a circumflex or shift 6. Yeah.
If I clicked to run the package, install package, and then it came up with a whole bunch of red
Right.
Just as long as it says warning, it's fine. If it says error, then you have a problem. But
Okay.
most of those will be warnings. They'll say it was created under a different version.
It's asking if I want to install sources.
You don't need to install sources because most of them have binaries available. But whether or not you say yes or no, it'll install.
Okay. Apologies.
No, please call me Toll and do interrupt because this is supposed to be interactive. The log function, as you can imagine, takes a logarithm. By default, like most packages, including Excel, it takes the base E natural logarithm. The exponentiate function, or exp, is e to the whatever, and so we should get 81 back as we do. There is a function for log 10 logarithms, should you need to take them. It's just log 10. And then, of course, we can exponentiate and get 81 back again. The round function rounds to a fixed number of decimal places, and there are obviously hundreds of functions, and I was just giving you some examples. So sine pi over 2 is the sine of 90 degrees, and cosine pi over 4 is the cosine of 45 degrees. And there are, somewhere on the page, there's a link to a long table of built-in mathematical functions. But just the main thing I want you to see here is how easy it is to enter them and how we use parentheses to separate the function call from the argument to that function. So here log, and then in parentheses we have 81. If we wanted the base 3 log of 81, we can, it's log 81 comma 3, and 3 to the 4 is obviously 81. So the log function will work to any base you feel comfortable with. Like any package, and again, all that I'm saying here applies just as much to Excel. Order matters. By the typical mathematical rules of precedence, multiplication comes first, and you can see this example. If we were to add 3 plus 2 and then multiply by 5, we would get a different answer than if we multiply 2 by 5 first and then add 3. So since I am never able to remember those order rules of precedence, I use parentheses to make sure the order of operations is as I wish it to be. So what happens in parentheses, what's in the parentheses gets done first.
Is there a way to, I know you put the hashtag to make it that this is a comment.
Yeah.
Is there a way to write in a different color if we're wanting to write notes in the system other than what notes that come with your file?
Oh yeah, you just do it as a comment. Oh, it'll still come up green.
Okay.
But you could use 2 hashtags. You
Okay.
could
This was, as you're talking, you're saying things that would be helpful to keep track of. Okay.
I really tried to make this code a template so that you would have it going forward. So the equal sign is a bit confusing in many statistical packages because equals does 2 things mathematically. As you see here, it assigns x to something. So I'm setting x equal to this thing on the right-hand side. But mathematically, x equals 7 is also a test of does x equal 7 that returns true and false. And this creates a lot of confusion in many languages. So the inventors of S said, we don't want that confusion. So in fact, they didn't have an equal sign for assignment. They had this arrow operator. It'll be easier on your heads if you just use the equal sign to assign things like x equals 7. But I wanted you to be familiar with the arrow sign, and I'll talk about it just because you will find it online, and I didn't want it to confuse you. So there are many different data object types in R, just as in any language. There are matrices, arrays, lists, data frames, and more. And we're not going to talk about all of them. We're going to talk about 2 that will be enough to get you by. And the first and most simple is what we call a column vector, or a vector. And it's just a column of numbers. And the way, if you have to create a column of numbers, normally you're going to read it in from an Excel spreadsheet, but if you have to create it by hand, I've done it here. X equals C for column. Actually, C is for concatenate, but column is easier to remember. So here I've created a column of numbers from 1 to 12. Here I've used the other equal operator, the arrow operator, to assign it to X. And here, this is one of the advantages of the arrows, is I can assign in both directions. So some of us geekier types, you will find, use arrows. And I apologize. By default, I use arrows because I learned on S where I didn't have the equal sign. If I run that first line, you will see an object has now appeared over here that says you have created a numeric vector, X, with 12 elements. And the same thing, the other versions of that assignment do the same. please notice that nothing displays when I created X. I have created it, but it doesn't show me what I've created. And the reason for that is because you may not want to see 300,000 lines with 1,200 variables. So if you want to see it, then you just say, after you create it, you say display X. You just put X, and now I get the column of numbers that I've created. Or if you're feeling verbose, you can say print X. It's exactly the same. So we have created here a column of numbers called a vector, and that terminology is kind of our jargon, and much of what I'm doing today is what we call the boring bits of introducing you to R's logic. And so every system has its logic. Anybody who uses one system will find this other systems confusing. Stata confuses me because I started on SAS. It took me years to untwist my brain from SAS's peculiar logic. But I think you'll find that ours is fairly straightforward, and especially if you stick with the examples we're doing. Once you have a column of numbers, most functions will operate on a column. So for instance, the mean function will take the mean of that column, which in this case is 6.5. Now, whichever system you're using, it's important that you know how that system keeps track of missing data. So in Stata and SAS, a period is used for missing data. In R, we use NA, which is not available. In Excel, Excel is kind of free verse, and we'll use 9999 or period or whatever symbol you choose, and this can be very problematic because 9999 is a number, and people hand me off data sheets and say, please do calculations, and they don't give me a data dictionary. So I don't know that 9999 is a number, and it gets used to calculate the mean or anything else. So I urge you to always create a data dictionary saying what type of numbers are in each column, or what type of data is in each column. Sorry, what type of data are in each column. Data is plural. And also what your missing indicator is. So here, I've created a new vector called x missing, which is the same as the old x, except I now have a missing number. And if I apply mean to it, nothing. I get a bad answer. And some of you may say, well, that's a bug. It should know that I want the mean, not including the missing one. But it's not a bug. In our lab, hemoglobin A1C is greater than 14 don't get calculated. So you get a missing data indicator. And if you take the mean and you don't pay attention to that, anybody who's high is being ignored. It's biased. So R is just reminding you that you have to tell it how to handle missing items. So now what I really want to do is I want to take the mean and I want to say ignore the missing. And I do that by saying NA remove equals true. And if I run that command, I now get the mean is no longer 6.5 because I had this missing value, and I've simply ignored that. The same is true of other functions like standard deviation. If I want to calculate the standard deviation out of missing elements, I have to tell it how to treat the missing elements. There are obviously hundreds of functions. Length of x is a useful one because it'll tell you how long x is as a vector, and so in this case it has 12 elements.
When you create the vector, you don't have to tell the computer how long it's going to be?
No, it will, as you saw, we just created it by listing its elements. The same would be true, as we'll see when we read it in from an Excel spreadsheet, is it'll calculate, it knows how many rows are in the spreadsheet.
Okay.
Does capitalization matter anyway?
Yes, so R is case sensitive. That's a very good point. Capital X is different than lowercase x.
So in that NA.RN, it's a small NA?
Yes.
Versus a big NA?
Yes.
Is that purposefully done?
NA are most, for convention reasons, most arguments to functions are lowercase.
Okay.
But capital NA is used for missing.
Or when you're changing your data, when you're making your data? Okay. If you had a small NA, would it identify it?
No, it would think it was a variable or something. Yeah,
okay.
yeah. So you have to be careful. And periods are allowed in variable names. So x, I could, instead of x underscore missing, I could have done x period missing. And not every system allows periods in names, but R does. again, please feel free to interrupt. Now, when we're working with vectors, most operations that we do, like if we say divide x by 2, will act on each element of that vector one element at a time. So in fact, if I say x divided by 2, I get every element of x divided by 2. And the same if I take log of a vector, I get every element of x has its logarithm taken. If I square x, every element gets squared. Now I want you to notice something here. Here I created a new variable y. I've set it equal to x squared. And if I didn't have this bit, nothing, it would appear over here, but it wouldn't show me the value. So what I've done is I've said semicolon, which is just the standard way of saying start a new line, and then I said, and now show me y. And the only reason I've done it in one line is because I really want it to happen together in this case. So that just so you don't get confused. We've been talking about numeric vectors and numeric functions. The other important and useful type of vector contains what we call string data or character data, so text. And here I'm creating a 3-element vector, so I don't have to tell the length, I just have to list the elements, and I'm calling it P code, and it's a list of, or 4 elements, sorry, of 4 postal codes. And now these are not numeric data, these are string or character data. And there are functions, and you can find a list of all of them, for string data as well. And just to give you some useful ones, nchar is the number of characters. So it tells me that each one of those postal codes has 7 characters.
Quotation marks are just to indicate that
that is text, that's right. And single quotes work just as well. Though they do need to match. If you use double quotes on one end, it needs to be double on the other. So substring is a very useful command. In this case, I'm saying take characters 1 to 3 from that postal code. And I get, for those of you who are into such things, that's called the forward sortation area. According to by Canada Post, it's the first 3 digits of the postal code, and it actually tells you quite a bit about where the person lives, but not as precisely as the full postal code. And the reason I'm showing you that command is it can come in very handy because almost always your medical charts have 7-digit postal codes, but if you're working with them, you need to get rid of that space. And if you're doing a Canada-wide study, you could have 875,000 postal codes. You are not going to go through them and remove every space by hand. That's where commands come in handy. So here, I've just combined functions. This substring command says take the first 3 characters of the postal code. This substring command says take the last 3 characters of the postal code, separate them by no space, and paste them together. And that's a complicated command, but you can see how I could have taken all 1.6 million or 875,000 postal codes in my file and got rid of the space.
What's the Sept equals?
So it's what I want to be the separator. If I wanted the first and last 3 digits to have a backslash between them for a date, I could say Sept equals backslash. In this case, Sept equals nothing. I want a blank. And so the paste command is a very useful command for manipulating text data. And I wanted to show it to you because I wanted to give you some idea. This is where commands come in handy. Imagine trying to do that with a point-and-click interface. It can't be done. You need to be able to manipulate text. This is as good a time as any to show you how to get help. Question mark mean will bring up a help window on the arithmetic mean, and it searches base R, which is the core R, and it searches any packages that you have loaded, but it doesn't search your entire library. 2 question marks followed by mean takes a bit longer to generate, and will pull up a list of every function that contains mean in it anywhere on your system. Okay, so if all you know is it has something to do with the mean, you can pull up the whole list. The apropos mean function does what's called a fuzzy search, which searches for things that may be related to mean. And RStudio actually has a nice feature. If I type in the first few letters and then hit tab, I get a list of everything, in this case it starts with ME. And so help is very easy to get.
Try repeating that.
Sorry. So just type in the first few letters, as I've done here, and then hit tab, and you get this list that you can browse through.
Does that only work in the script, or that works in the code?
Actually, I'm down here in the console window,
okay.
So it works in the script window, the console window, wherever you enter. I think, actually, yeah, it works there too. So that's not in R, that's an RStudio thing. If you want help on one of the packages that's installed in your library, by the way, I was mentioning Brian Ripley earlier, if you use library to refer to a single package, you will get a reply from him that says, don't you know the difference between a library and a package? The library is all the packages are the individual add-on packages. So here, I'm asking for help on a specific package. And it's a package we will use called ReadXL. And you can see here, I pulled up the help for that package, and there's only two functions in it. One that lists all the sheets in the Excel spreadsheet, and one that reads in Excel files, and I can get help on the details on those functions. If I want to load that package, there's two ways I can do it. Actually, there's several ways I can do it. I can go down here to the package window and click on it. But the usual way we do it is library, and then the package we want to load. So library ReadXL will load that package, or require ReadXL will do exactly the same thing.
I don't have ReadXL as a package.
Oh, it should have been on the list, but it's okay. Don't worry if you don't have it. I don't really use it. It's just an example. I'll show you how to read in data without it.
Okay.
So, but it should have been installed with the install packages list.
Even mine doesn't have
Actually, if you want right now, just type.
install.package.
ReadXL is checked off on my packages
Yeah.
as a download, but when I press to go, it just says library ReadXL load package into active workspace.
Yeah. So, but if you type library ReadXL, does it, or if you just run that line?
Yeah, then it pops up this ReadXL load package.
Probably because you already have it.
It should load when you do that, and it should then be checked in here as a loaded package.
Oh, because I already have it, it's telling me it can't download it, maybe?
Oh, you don't need to download it if you already have it.
Okay.
So you don't need to run install packages again. You just need to load it using the library command.
Okay.
Okay. So this is how R avoids having 50,000 packages loaded that you're not going to use loaded at once. There's another package we will use called CAR, which is, it actually accompanies this book, Companion to Applied Regression, which is a very good book on regression models by John Fox and McMaster. And so, just in contrast, if you ask for help on CAR, you will see there are more than two functions. In fact, there's dozens and dozens of functions. And just so to give you an example, if you want a citation on a specific package, here I'm asking for citation for the CAR package, and it'll give me a reference in a standard format for the book, for this particular book. There are thousands of packages. It may be difficult to, and that's true for any system. If you're using SAS, you often end up using macros created by someone at York University or something like that. I would urge you to stick with packages that either come with base R or that have a book associated with them, just so that they're well documented, or a reference when you do the citation. Many of these packages are described in the Journal of Statistical Software, and so if there's a book associated with it, or there's been an article in the Journal of Statistical Software, it's well documented, and you're going to be safe using it. So that's just a general guideline. We can load the CAR library exactly the same way as we loaded the ReadXL library, and you see it takes a few seconds there to load, and it should now be loaded.
So it's something like that, like I didn't have the car in
Okay.
my box,
Yeah.
so I went to try to load it, and it just says error in load, package or namespace load failed for car,
Okay.
and then there's a lot of red.
Okay, so I'll tell you what, we're not going to use CAR today, so afterwards I'll look at it with you if there was a problem downloading it. So we're going to create another vector here called x again, and x is now the numbers 1 to 10.
Can we delete all the vectors that we
Yeah.
have loaded?
Yeah, and I'm going to show you how to do that in a second, but not yet because I want them still to be there for a moment. So there's another way that we could create that using the sequence command that I'm just showing you for future reference. If we want to create a sequence of integers, in this case from 1 equals 10, in steps of 1, we can use the sequence command, and it will create the exact same vector. I want to create y, which is the square, and z, which is the cubed. So we've learned about vectors. I'm not going to talk about lists or matrices or arrays because you won't really need them, and if you ever do, you can read about them in one of the references. But I want to talk about data frames because that's really what you're going to work with for the most part. So a data frame is just a spreadsheet. It's the R word for a spreadsheet. And usually we're going to read our data frame from Excel or some similar package, but we can create it within our code if we want. So here I'm using the data frame command and say make 3 columns, X, Y, and Z. And you'll see that that has now appeared over here, 10 rows with 3 columns. And if I want to see just the first 6 rows, I can say show me the head of Z, and it will. I can also click on the name over here, and it will bring up the spreadsheet that I've created. Not on the arrow, on the name, so you can view the spreadsheet. So a data frame is just a spreadsheet. In this case, the names of the columns were X, Y, and Z because that's what I used to create them. But I could change the names when I create the data frame by specifying here X1, for X1 use X, for X2 use Y, for X3 use Z. And now I'm using the tail command to look at the last 6 lines, and you can see that it's the same data, but I've changed the names. So you will rarely have to create a data frame this way. Usually you'll be reading it in from an external file. But this very simple example is we're going to use to illustrate some useful points. One of the major things we do with any data set is subset it, which means we extract parts of it. So if we have a vector y, and we want to just extract the 4th item or the 4th element of y, we use square brackets, and that's called an indexing brackets. And I can choose any number from 1, and it starts at 1, not 0, as it does in some other languages, from 1 to whatever the length of y is. So if I click this line, I get the 4th element of y, which is just up here you can see is 16. So that's one way to extract an element of a vector. The other way to extract an element of a vector is using logical comparisons. So I told you that equals can also be a test for whether something is equal to something else. In R, we use 2 equal signs in a row. Actually, this is true in Excel and in most languages. 2 equal signs in a row means test. Is y equal to 9? And if we do that, you'll see we get a whole bunch of trues and falses, which is now what we call another vector, but it's a logical vector that has only 2 values, true and false. And the fourth one is true, because that's the one that where y equals 9. Or sorry, the third one, where y equals 9. And the same, I can say, tell me which elements have y less than 9. And you'll see that the first 2 elements, which were 1 and 4, have come up true. And I can use a logical comparison. This is why it's important. I can use a logical comparison to extract elements. So again, I use my square brackets, and I say, pull out all the values where y less than 9 is true. Okay? And so this is different than SAS or Stata, where you use the where or which modifier, but it accomplishes the same thing. So now I'm saying, please show me in y any elements where y is less than 9, and I get the first 2 elements, 1 and 4. I can also do exactly the same thing with the subset command. And the subset command you will find very useful. So here I'm saying subset y, and what I want to extract from y is all elements where y is less than 9. And I'm going to call that y2, and when I look at it, I get the first 2 elements of y, because that's what I subset. Now, in answer to your question, Jonathan, the RM, or removes all those x, y, in this case x, y, and z. So if you run that command, they've now vanished from over here. And the reason I wanted you to save, and so now if I say show me x, I get an error because x no longer exists in my global or top workspace. However, I created a data frame that had variables x, y, and z in it. They're still there because I didn't remove the data frame. So if I say show me D, you'll see I still have an x, y, and z in D. And this is really an important distinction because I typically have 25 data sets open. They often have variables with the same names. I have to know where those variables live. And there's a difference here, the distinction between living in my topmost object environment, where I can refer to them directly, and living inside a data frame. And so if they live inside a data frame, we need to know how to get access to them. So I still have X, Y, and Z. The one common way to do it is specify when I say I want to see X, I specify which object it comes from. And I do that with this $sign operator. It's called the slot operator. So $X will get me the X that's in D. But as you saw a moment ago, if I just ask for X, I get nothing because there is no X in my global work environment. So I know that sounds arcane, but this is called, in any programming system, this is called the scope of a variable. And it really matters, because otherwise you're going to say, take the mean of birth weight, and you're not going to be clear. So the way many systems work with it, Stata, for instance, you can only have one data set open at a time. So if you want to subset just the males from your data set, you have to throw away all the females, create a new data set where you just have females, or use a where command. I know you're supposed to. But most systems deal with it by saying you can only work with one data set at a time. R has an advantage, and it is an advantage, is that I can have multiple data sets. I can have the males in one data set, the females in another data set, the white babies in another data set, whatever. And I can work with any of them as long as I specify what the name of the data frame is when I ask for the variable. So that's a very important feature of R. And you will notice that I don't use data frame names like, this is my example from September 25th, because that's too long to type. But there's nothing that stops you from doing that. I think you're allowed up to 256 characters. But I tend to use D or D1 and D2 just because if I'm going to refer to them again, they're easy to type. So one way to ask to see X within D is this $sign operator. The other way, as I said, is to click on D over in my environment window, and I can see the whole spreadsheet. View D does exactly the same thing without clicking. So now let's talk about D, not the individual X, Y, and Z. We're now talking about our data frame, which is our spreadsheet. So again, I can subset it by using the square brackets, the index brackets, and here I'm saying pull out the 5th row and first column. Rows always come before columns. That's a basic mathematical convention. Here I'm saying pull out the 5th row, and I'm leaving the column slot blank because I want to see all of the columns. So here, the 5th row of that data frame, X, Y, and Z, I got all columns. Similarly, if I leave the row space blank, I can say pull out just the first column, and I get the entire first column, all the rows. I can pull out multiple columns or multiple rows by creating a list or a column, within the data frame. So here, using the C operator, I'm going to ask to pull out just columns 1 and 3. And here, this is convenient at times, I'm going to ask to delete columns 1 and 3. So the only remaining column will be column 2. So the only difference there is I put the negative sign in front of the list of columns that I want to extract. So it's just all.
That would be the same as like calling up line.
Yeah. And so in fact, as we see in the next line, we could also call columns by name. So here I'm saying D, show me the column named X. Or here, show me the columns named X and Z, and I'm calling them by name. I get exactly the same.
Can we name rows as well? Or just...
Yes, you can actually. In fact, when you create the data frame, there's an option, if you look up the help on the data frame function, that says row names equal, and you can provide either a separate column or a list of row names. Okay. By default, they come up numbered. And usually, rather than naming the rows, we have a patient identifier as one of our data columns. So that's why I didn't cover it, but yeah, you can. So very frequently, you will want to subset your data. So for instance, we do MCHP studies, and we're interested in newborn babies in the last 10 years who born to mothers with diabetes. Well, they don't give us those data. They give us the data on every baby born. And so we've got 1 million observations. I'm not going through and cutting and pasting. I have to be able to subset those data manually. And so one way to subset is, again, using the square bracket index extractors. And so here I'm saying, I'm creating a new data frame called D2, which is just D, but I'm extracting all those rows where X is equal to 5. So remember, X equal 5 will give me a series of true falses. And so when I click that, I get the 5th row. And if you run just that part of it, you'll see you get the series of true falses. So again, I'm just using logical operators to extract specific rows. Here, I'm creating D2, and I'm using the not equals operator. So I want every row of D where X isn't equal to 5. And so you see I get 1, 2, 3, 4, 6, 7, 8, 9. By the way, Jonathan, this is your list. These are the default row names, which you could change over here on the left. 1, 2, 3, 4.
So exclamation mark. equals
Yeah.
is not.
And again, that's fairly standard in most statistical packages. Here, I'm asking for all of the x's less than 5, and again, I get the first 4 rows. I can do exactly the same thing with the subset command, and some people prefer that just because it seems a bit cleaner. So here, I'm going to subset D wherever x is less than 5. Here I'm getting a little bit more nuanced. I'm now subsetting D x greater than 2, and this is a logical and. So I'm saying x greater than 2 and x equal to 5. So I should only get rows 3 and 4, which is what I get. Okay, and the vertical bar. So that's the shift 7. The vertical bar is over on the right-hand side. Typically, is the logical OR. So in this case, I'm saying subset D wherever x is equal to 5 or x is equal to 10. So I should just get 2 rows. Row 5 and row 10. And this is a useful thing to file away in the back of your mind. If I have a long list and I only want to extract certain elements of it, here I'm saying pull up subset D wherever x is in this vector. So in this case, I'm just asking for x in 5 and 10, but you can see how I could have, if I had multiple categories, I could have I could pull up where race is Inuit, Métis, or Cree from a long list of 32 different ethnicities.
So those could be like words rather than
It's quotation marks is the only distinction. So yeah.
So if it's quotation marks, capitalizing and like spelling will matter a huge amount, right?
It will. The spelling, the case will matter again, and spaces also matter. 2 spaces is different than 1 space. So these are, I know this seems mundane, but these are essential skills for any package you're using. There's one other basic idea I want you to be familiar with, because R is kind of unique in R. It's called the formula notation. So y tilde x is the way we tell R that there's a relationship between the left-hand side and the right-hand side. So we use that in the plot function, which we're going to learn about later. But here, this is just a plot of y versus x, where I've specified the data frame that I'm pulling y and x from as D. And so that's just a scatter plot. And you'll see the plot function, if you look at the help, is very versatile, because I can make a point plot by saying type equals p. I can make a line plot. I can make both point and line. I can make a stair plot, or I can make what's called a high density vertical line plot. And we're going to learn about the plot function later. I'm really trying to show you how this formula notation works. One of the nice things about R when you're making plot is you can layer one layer after another. So here, plot y versus x gives me my vertical line plot. Then I use points, which is just a version of plot that says make points, to add points to that. And then I use lines, and I'm using the same formula notation each time to add a dashed line to the same thing. So I'm just trying to show you that R is actually quite versatile, and that you can create layered plots that are fancier than you might imagine. If you look up the help on plot, you will see there are many, many options, and some of them will be useful. So I might, for instance, use X label and Y label, which give me different X labels and Y labels, axes labels, and main gives me a title. So I get the same plot, but now I have labels and titles. Here I'm using X limit and Y limit to zoom in on this graph. And so when I run that, I'm now restricting the graph. Obviously, to use some of these functions like colors and symbols, we need to know what R is using, and the Frank Harrell's miscellaneous library has some nice functions. So if you load it and run show color, it will, for example, show you the color codes that go with the 100 colors that you can access. Similarly, if you say show pH, you'll get the codes, ignore the warnings, you'll get the codes for 101 different plot symbols that you can use. So these are the kind of options to plot, and that's just so you know where to look. So here, I'm taking a plot and I'm dressing it up. I'm creating line and point plot, both. I'm using plot character number 19, which is a dot. I'm going to set the color to red. I'm going to join them by dash lines, and I'm going to add some titles and labels. And you see you can customize your plot.
And then if you want to export that, you don't ever have to write it up there, you just go export it.
You can actually, there is code that will save it automatically, because, for instance, when I create the website, I don't want to be saving those figures, so it saves it. There are commands that save it, but for your purposes, you're just going to use this save. And PDF is a good way to save it, because you can convert a PDF to any format or resolution. So you can see that I can take that graph, I can add another layer to it using the points command, and I'm not going to show you how to use it, but the legend command is another way to pretty up your graphs. You have to tell it where the legend should appear, you have to tell it which plot symbols to use, which lines to use, which colors to use, and which legend text to appear beside each combination. So you can follow the model. I'm really just trying to introduce you to the formula notation. Formula notation is also used in statistical modeling. So here I'm using the linear model function, which we will learn about next week, and I'm using the linear model function to to do a regression of y on x. It also uses that formula notation. And again, model 1 has now appeared over here, but nothing has happened, and nothing will happen until I ask to see the results. So if I ask to see the summary of model 1 that I just created, I'll get the regression output that we'll learn about next week. I mentioned this just to emphasize that R is what we call an object-oriented programming language, which means that it creates objects, and objects have lots more built into them than what we're shown. So in fact, R shows us nothing by default. In contrast, SAS shows us 300 pages by default, whether or not we want to see it. So R doesn't show it to us until we ask for it. But because it's an object-oriented language, it knows how to respond to queries. So summary says, give me a summary of the regression. If I say plot model 1, I get a whole series of diagnostic plots that I can click through, and we'll learn about diagnostic plots when we do regression. So in fact, I know I'm just about to finish. If we do names model 1, you'll see a list. You'll see a list of all of the built-in data within Model 1. You can see we get residuals, fitted values, regression coefficients, and we can ask for any of them to be displayed. So there are the fitted values. There are the residuals. And we can create diagnostic plots, or we can work with these. So there's a lot more under the surface is what I'm trying to say.
When we save it, when we've done work, are we saving a specific window and it reruns each time, or are we able to save what we've, how does all that work?
Okay, I would usually recommend that you save your code, your script, and then you can rerun it. But in fact, you can save, and we'll learn how to do this next time, you can save a data frame that you've customized. You can save you can save your entire workspace, all the variables you created, and in fact, it may ask you when you first run it, when you try to quit, do you want to save the workspace? Say no, because the problem with that is that you don't remember what was in your previous workspace, and it may confuse your subsequent analysis. So I usually save the code and rerun it.
Okay, even if, we won't be doing big data sets.
Sorry, we won't be doing it.
I was going to ask about, in large data sets that take a long time to run, but that is about perfect.
Well, no, actually, that's where I do save data, and I'm going to show you how to save a result. So in fact, we could save that regression model, and I'll show you the commands to do that in the next session. The next thing I want to talk about, and we're not going to have time today, is how do you import a data set from Excel, and I would like we will go over this next time. Sorry, I wasn't clear on whether I had an hour or an hour and a half today, that's why we're not getting to it, but we will do it next time. If you have a chance to read just this section on importing this low birth weight data set, here's the data dictionary telling you what the variables mean, we will go over it next time. So that, I apologize that was boring, but you will be surprised, I think, by how powerful just understanding that logic can be when it comes to taking a data set and working with it.